Okay, as promised, sorry it's a bit late, help video for the review packet for the post-test that we'll be taking on Wednesday and Thursday next week. So, first up is solving by graphing. Solving, again, means to find, in graphing, where the lines intersect, or what values of x and y exist, such that it makes both these statements true. So I'm going to graph these. The first thing is to identify the y-intercept. So for line 1, it's that number 3. Problem 1. So that means I'm going to put a dot at 3. That means that on the y, there's a 3. Next, I'm going to look at the slope. The slope is the number I'm about to circle in red. And it's negative 5/3. Now, recall slope is rise over run. And if it's negative, that's important. So, so that means the rise is negative 5, and the run is 3. So if I go to the right by 3, 1, 2, 3, I would then go down by 5. 1, 2, 3, 4, 5. Okay. So there are 2 points for my first line. Now I'm going to connect the dots. Let me get my line tool. Oops, that's not the right thing. That's beautiful. So there's my first line. Okay. Next up, my ruler tool. I'm going to make a look at my second equation. And notice the y-intercept here. I'm going to circle it in a greenish color. Is the negative 3. Now be careful. It does have to be. We do have to notice: is it negative or positive? Is it negative 3? So I'm going to put a dot on my y-axis at negative 3. Then I'm going to look at the slope. The slope here is 1/3. That means I go up 1 for every 3 to the right. So I'll go over by 1, and then up 1, 2, 3. Oh wait, sorry. Oops. Yeah, sorry. The run is 3, the rise is 1. So if I go over by 3, I go up by 1. 1, 2, 3, 1. There we go. And now I'm going to make my line. My ruler tool. Dots. There we go, and now I'm going to draw my line. Okay, so I'm done now. My solution is right here where the lines cross at point 3, negative 2. 3, negative 2 is my solution. For the next one, same process. First, I'm going to, this time I'll just make this line red and the other line blue. So I notice my y-intercept is at 3, because the number without the x is 3. So I'm going to find the number 3 right here. And my slope here is 4. So if I go over by, now if you're maybe confused because you don't see a fraction here, recall that 4 is the same as 4 over 1. So that means I go, my run is 1, my rise is 4. So if I go to the right by 1, I go up by 4. Now, I see if I go right by 1, and up by 4, 1, 2, I'm out of room here. So I can go to the left if I want, and then go down by 4. They'll have the same effect. So left by 1, down by 1. And then I'm going to get my ruler out and connect the dots. There. So there's my first line. Now in blue, I'm going to do my second line. Okay, my y-intercept is negative 2. Put a dot at negative 2. And my slope is, it just says negative x. So what does that mean? That means my slope is negative 1. So it's the same as negative 1 over 1x. So that means if I go 1 to the right, I go down by 1. So there we go. Get my ruler. And there we go. Pretty close enough. Looks my solutions should be right here. I didn't do that second one perfectly. It'll be there at a -1, -1. So that's how we do the graphing by solution solved by graphing. So okay, the first problem asks us to do the following. Asks us to solve by substitution. The first equation was y. Just let me make this bigger. Y equals 6x minus 11. And the second equation, in blue, was negative 2x. Should be blue, sorry. Negative 2x minus 3y equals negative 7. So substitution means I'm going to replace something with something else. So here's what I'm going to do. I'm going to copy what y is up here. The first equation tells me that y equals 6x minus 11. Oops. And now, so on the second equation, I'm going to paste that right there. It's important that I use parentheses. So that's what substitution means. It means this was a y, but now I've replaced it with what y is. And now I distribute. So I'm going to distribute. It becomes negative 2x minus 18x. This is, be careful here. It's going to be plus 33. It's negative 7. It's plus 33 because I have to distribute the negative 3. Negative 3 times the 6x, that's the negative 18x. And it's negative 3 times negative 11. So negative times negative, positive. We get this. From there, we are going to do our combine like terms. So the next step is combine the negative 2x and the negative 18x. Get negative 20x minus 18x. Sorry, negative 20x plus 33. That's negative 7. Now we're going to get all the constants to the right. So we'll subtract 33 from each side. Get negative 20x equals subtract 33 negative 40. And from here, clear x is 2. And if x is 2, now I can look back at my first equation and solve that. So y equals 6x minus 11, but I'm going to put not x, I'm going to put my 2. So y equals 12 minus 11. Y equals 1. I want to verify that's true. My other equation, kind of a good idea, does minus 2 times x, which is 2. Minus 3 times 1, which is y, equal negative 7. That's negative 4 minus 3. Yes, that is true. Okay. Another way to do this, which is the way I do it, so maybe that's worth showing. Let me just find my Wabbit emulator.
Oh, good. It's very true. Okay.
Nice.
I'll talk to you later. Bye-bye. You a bunny, Elena? Can you show me how to hop? I don't actually know how. Oh, you're really good at it.
Okay, so So let's look again at that first equation, because I have to do one thing to it. This is the way I recommend doing these. So let's look actually at the second problem, where it says 2x minus 3y equals -1, and the second equation, y equals x minus 1. Now what I want to do is I want to rewrite everything so that all my x's are in one column, all my y's are in another column, and then equals a number in the third column. So this one's already in that form. It's 2x, sorry, positive 2x's, minus 3y equals -1. And this one I do have to change something. I have to subtract an x from each side here to get all the x's and y's on one side. So I subtract an x from each side, and I get a -x plus y equals -1. So here I put -x plus y equals -1. Okay, so now that we're here, we're going to get a calculator out and let the calculator solve it for us. So I'm going to hit the matrix button. Matrix is right there. It's in blue, so that means I hit the second button to get there. I'm going to edit a matrix. Hit enter to start that process. It's going to be a 2 by 3 matrix. Everything for this class, if you want to use this method, will be 2 by 3. And here I have room for 6 numbers, and I'm going to use the numbers over here. So my first equation was a 2x minus 3y. So I've got to move this to here, negative. Minus 3y equals -1. And my second equation was -x, which is -1x, plus 1y equals -1. Now that I'm here, I have that all entered. I'm going to quit out. I'm going to hit matrix again, and I'm going to do a math operation on it. So I'm going to go to my math menu, and I want to do RREF, which stands for Reduced Row Echelon Form. You don't need to know that, but now you do. Hit enter, and I have to go matrix one last time and put in my matrix. So I'm saying do a reduced row echelon form of matrix A, and there's my answer. It tells me that 1x equals 4, and 2 equations, just like solving by substitution elimination. Our first step I would do is read the problem, understand what it's saying. Brenda's school is selling tickets to a spring musical. On the first day of ticket sale, the school sold 3 senior citizen tickets and 9 child tickets for a total of $75. The school took in $67 on the second day by selling 8 senior citizen tickets and 5 child tickets. What is the price of each of one of the senior citizen tickets and 1 child ticket? So if you get a lot of information like that, you know you're going to have to do more than one equation. And you do have to learn this method, because doing this in your head, you can't. It's not something that I can do, so I'm not going to assume that you can do it. Most people can. I'm told here basically what my variables need to be, because they're asking what is the price of each senior citizen ticket and child ticket. So I'm going to make 2 variables, S for senior tickets and C for child tickets. And I'm going to make 2 equations with those. The first equation is from the first sentence with any numbers in it. 3 senior citizen tickets, so that means 3 S's, and 9 child tickets, so plus 9 child tickets, that's $75. Next, on the second day, $67, that's our monies. Selling 8 senior citizen tickets, so 8 S's, and 5 child tickets. I've got 2 equations, and I can now solve. I'm going to use elimination for this. I'll not use the calculator, because I just realized I didn't do elimination before. Elimination, the goal is to eliminate either the S's or the C's. Let's see. Now, the S's, this is a 3 and an 8. I can't just double S and get that. 9 and 5, 75 and 67. So the 9 and the 5, they're not the same. So I'm going to have to multiply both these equations. That's okay. So I want a common factor. Let's see, I'll find the kids first. So I'm going to multiply this top equation by this number, 8, and the second equation by this number, 3. What this is going to do is they're going to have the same number of s's on the top and the bottom. So this equation is going to become 8 times 3, that is 8, 16, 24s. 8 times 9, that's 72. See? And 8 times 75, let me get my calculator quick. That's 600. And my second equation, 3 times 8, that's going to be 24s again. Oh, and I really should have done a negative 3 here. So I'm going to make all these negative, because I want to be able to add them and get rid of it. Negative 3 times the 5, that's negative 15c. And negative 3 times 67. 3 times 67. 201. So now I'm going to add these two equations. And the whole goal of this was if I add the 24 s's minus the 24 s's, I get 0 s's. So 0 s's plus 72 kids tickets minus 15 kids tickets. So 70 minus 15 would be 55, 57. 57 kids tickets is 600 minus 201, so that's $499. So that means one kid's ticket, $499 divided by 57. 875, right? So I'll check my work in a bit. And now if a kid's ticket is 875, well then I know that, we'll do this up here, 3 senior tickets plus 9 kids tickets at 875 each. Here's 75 bucks. So the 9 times the 875. Can't be kids. Can't be free. I made a mistake somewhere. This is why I'll just use the matrices. But let me just find out where my mistake is, so I feel better. Okay. 600 minus 201. Is that where my mistake was? 399. Oh, it should be 399, not 499. That's where my mistake was. Okay, so how many kids tickets did I have again? 57. 57 divided by 99. I did that in the wrong order. $7 for a kid's ticket. So that means that 3 senior tickets plus 9 times 7, that's $63. Is going to be $75. So that means 3 senior tickets is going to be 75 minus 63, so that's 12. 3 senior tickets is $12. That means 1 senior ticket is $4. So 1 senior ticket $4, 1 child's ticket $7. Now that takes a while, which is fine. But again, we can use the matrix thing instead. Because that really is faster. So from here, I just need to put in my numbers that were there initially, which was the 3 kids tickets, 3 senior tickets, plus 9 kids tickets was $75, and 8 senior tickets plus 5 kids tickets was $67. matrix menu. I go to math and I find my reduced row EF, reduced row echelon form. Whoops. I did quit sometimes. A little bit wrong. I still have everything filled out, so it'll be cool. Our EF, I put in my matrix A, which I just edited. Close my parentheses, hit enter. And get the same answer. 1 senior ticket, because I put all my senior tickets in my first column, is $4. 1 kid's ticket is $7, so that's much faster. Alright, and that's it.